In the world of logic, a statement is a sentence that can objectively be labeled as true or false, but not both. So if I look at this picture and say, this is a purple cow, I've made a statement. It's a statement because I can objectively say, yes, that's true, it is a purple cow. If I say pigs can fly, I've also made a statement, because objectively we can decide whether that statement is true or false. In this case, it's false. Pigs can't fly. So it's important to remember that a statement can be determined to be either true or false, and yes, false statements are still statements. If I say snakes make good pets, I haven't made a statement. And that's because, is there really an objective way to say whether snakes make good pets? Some people would say they do, and some people would say they don't. So even though we've said a sentence, we haven't made a statement in the world of logic. Now, when we make statements, we can make either simple statements or compound statements. So far, the statements that we've seen are all considered simple statements. They contain only one idea. So saying, I finished my homework last night, or the moon is made of green cheese, are both simple statements. They convey only one idea. On the other hand, a compound statement combines two or more simple statements. So if I say, I'll either eat lunch at McDonald's or at Taco Bell, I've combined two simple statements. And if I say, if you buy the movie tickets, then I'll buy the popcorn, I've also combined two simple statements to make a compound statement. Now, if we think about how we combine those simple statements, we have to use connective words. Connective words are and, or, if, then, and if and only if. Now, each of these connective words also identify the type of compound statement we have. If we use and, we have a conjunction. If we use or, it's a disjunction. If then is a conditional statement, and if and only if is a biconditional statement. Sometimes when we look at a statement, we see what we call quantifiers within that statement. Quantifiers are words like all, every, each, none, some, or at least. A statement like all birds can fly is a quantified statement. Some coins are quarters, or no M&Ms are yellow, are also quantified statements. Once again, the statement could be true or it could be false. Negations are related to statements in that they have the opposite truth value of the statement. So if we look at our statement, this is a purple cow, which we said was true, a negation of that statement would be, this is not a purple cow. If the original statement is false, then the negation would have to be true. Now, negating quantified statements can be a little bit tricky. We still have to remember that a statement and its negation have to have opposite truth values. So let's say we look at the statement, all birds can fly. That's a quantified statement because of the word all. Let's think about what the negation of that would look like. And our first guess might be something like, all birds can't fly. So let's think about the truth values for each of those statements and see if we've really come up with a negation of the original statement. So is all birds can fly true or is it false? Well, I can certainly think of birds that fly, but does that mean all birds can fly? No, there are some birds like penguins that can't fly. So if I make the statement, all birds can fly, I've said something false. Now that means that the negation has to be true. So think about our negation. All birds can't fly. Is that a true statement? No, that's not a true statement. So that can't be the negation. Saying all birds can't fly certainly isn't true because there are some birds that can't fly. But that's it. That's our negation. So the negation of all birds can fly is some birds can't fly. Here's something that might help you negate quantified statements. It's the relationship between the quantifier in the statement and the negation. So we just saw an example of a statement that contained the quantifier all, and the negation of that contained some do not. If our statement contains some do, the negation would have to be none do. The statement is none do, then the negation is some do. And if the statement says some do not, the negation is all do. The last thing we want to think about is how to take all these words that we're talking about and represent them with symbols. So going back to the connective words we looked at, we have special symbols to represent them. And is represented by an upside down V, or is represented by something that looks like a V. If then is represented by an arrow, and if and only if is represented by a double arrow. So if our statement is, I'll either eat lunch at McDonald's or at Taco Bell, we have to figure out what the simple statements are that make up this compound statement first. So one of the simple statements is, I'll eat lunch at McDonald's, and we're going to substitute the letter P for those words. The other simple statement is, I'll eat lunch at Taco Bell. We'll call that Q. The connecting word between those is the word or. So to put this completely into symbolism, we would write something that looks like this, P or Q. One last compound statement. I'll go to the concert and you can't stop me. So the first simple statement is, I'll go to the concert. The second simple statement is, you can't stop me? Now can't sounds like a negation, doesn't it? So we're going to say that the second simple statement is, you can stop me, because can't would be the negation of can. Now, how are we going to deal with that notationally? Well, certainly we've got an and statement here. We've got a conjunction, so we know what symbol we'll use to connect the two simple statements. But we also need a symbol for that negation, how to change the can into a can't. And the symbol we're going to use for that is a tilde. It's a squiggle, and that's what you see in front of the Q. So this says P and not Q.